here for an assignment. It's the Amyngoo Oil and Gas Plant station to treat the water that is polluted with salt and iron deposits. So you can see the effects in this property. The level of destruction has done. It's been affected. That this tank has been affected. So it's already affecting everything here. You see the iron almost collapsing the structure. So that is the effect of iron and salt. And many people don't know about it. It is removable with our system called reverse osmosis water treatment system. This is the borehole. The borehole is here. It has enough water. You can see. You can see the water. It has enough water, and the water is even very clean. Now, but what's the challenge? The challenge of this borehole has high salt content and high iron content. There was an overhead tank here. There was an overhead tank here. But you can see how the salt and the iron destroyed this overhead tank. You can look at it. This whole thing collapsed by the attack of iron and salt, mostly the salt. Now, some places have this challenge. They have enough water. The water is not the problem, but the content of the water may be the problem. Sometimes it might be a heavy metal like lead, zinc, arsenic, mercury, and the rest of them. That water is clean does not mean it is safe. Water can be clean, but it's not safe. If you look at this, the geology of this area, for instance, it is conspicuous that the iron, the level of iron content is very high. Look at this. Look at the whole place. The level of iron content on deposit here is very high. People don't understand that safety of water is not in its cleanliness. Water can be clean, water can be pure, but it's not safe. This one you can see is very clean, it's very pure, but it's not safe. Now, there are people who are living around mining areas where they mine lead, they mine zinc. Most of the groundwater there contains lead, zinc, arsenic, and they are harmful to our health. Like most of them are carcinogenic. Carcinogenic means it's harmful to your lungs, harmful to your liver, harmful to your organic systems. So when we have this kind of situation, we want to let people know it is solvable. It can be solved. It can be treated. We want to use it to educate the public. When we say water treatment, you take the water to the lab, and after the analysis, you now know what is actually the problem of the water. So we know now what to treat. Because it's like human beings. You want to see a doctor. I just said to the doctor, I have pain here, I have pain here. The doctor will say, I'm not a magician, go to a lab, do a test, let us know what's happening to you. The same thing with water system. Sometimes you may just assume that you can treat water anyhow. It is not anyhow. If you do the water test, that's why we're getting this water sample. The chemical analysis, we want to know the chemical content of the water. What is in the water that is harmful or is not good. For instance, this one is called sodium chloride. The salt inside there is called sodium chloride. Now you have the iron content. We need to know whether it is iron 1, iron 2, or iron 3, or what's called ferric oxide. So if you don't know the particular ion, I say it is iron, the salt. Now you have calcium carbonate, you have calcium chloride, you have magnesium chloride. These are salt families. So you need to really know the particular kind of salt that you are treating. Sometimes in human beings, malaria and typhoid may have similar symptoms, but they are not the same. So if somebody has typhoid and you're treating malaria, you are not going to treat the person. So most times when people come to do water treatment, most times they get it wrong by just thinking that when they use this system, fill it with charcoal, carbon system, the gravel, and some other resins, it will just treat the water. Yes, for conventional water treatment, yes, you can just treat it to make it safe. But what of the chemical content? Because the chemical content, you have to be sure that the chemical content is taken care of. Now when we talk about the physical part is sort of suspension, impurities, colors, and all the color, taste, and odor. They are physical properties of water. After when we were in primary school and secondary school, they taught us qualities of a good water. Good water must be odorless, colorless, and tasteless. But when we go to the university and now we are practicing, we know that it doesn't end there. Even when water is odorless, colorless, and tasteless, it is still not safe. So now we add another one, safety. And what do we mean by water safety? We say water is safe or potable when it doesn't have any harmful properties or anything or any chemical properties that is harmful. And there are three major properties of water, like I mentioned before: chemical properties, physical properties, and biological properties. So let's talk about biological properties. Biological properties of water. We'll talk of microbes, microorganisms. We'll talk of E. coli. So sometimes a situation may arise in some places where the water is pure, the water doesn't have odor, the water doesn't have color, but there will be gastroenteritis properties. That is, if you drink the water, it will cause you gastroenteritis, a challenge or disease. We will be coming for this installation. We'll still do a video on how to install reverse osmosis water treatment system and how to install the one that is specifically for salt treatment and ion removal treatment process. Thank you very much. It's still CEO, Kutis Engineering Consult Limited, Rector and Founder of Kutis Engineering Academy.
This video was brought to you by Curtis Engineering Academy in partnership with Curtis Engineering Consults Limited.